Let's talk now about a very important issue, the water requirements of the greenhouse crops. Crop water requirement is the total volume of water that the crop needs to maintain its maximum rate of crop evapotranspiration, ATC. And the crop water requirements are calculated as the difference between the ATC and the water obtained from rainfall and soil water. This is a general concept of crop water requirement definition or calculations, but keep in mind that we are talking about protected cultivation and that we have no rainfall enters the greenhouses. And also the seasonal soil water extraction is negligible, very negligible in a greenhouse crop, because the soil is continuously close to field capacity, and that because we have or apply very frequent irrigations. And considering all this together, we should conclude that the crop water requirements of greenhouse crop is generally assumed to be equivalent of the maximum rate of evapotranspiration, the ATC. Indeed, and practically, the water required to maintain the ATC of a specific crop is the net crop water requirement. We have to consider also that we should apply some extra amounts of water to keep control on the rise of salinity into the soil, and especially in cases when we have not good quality water. We use water with relatively high electrical conductivity, and that's in these conditions the best method to keep control on the rise of the salinity is to apply overdoses of water in order to leach out the salts from the greenhouse soil. And next, some extra amounts of water are also needed to guarantee that we have water uniformly supplied to all the plants in a row. So altogether, the water needed to maintain the ATC plus the amount of water for extra water for leaching and uniformity of distribution form the so-called gross crop water requirement in a greenhouse. And we'll explain later that this is something equal to 15 to 25% of net crop water requirements. The ATC of major vegetable crops grown in soil in unheated plastic greenhouses is been experimentally determined in some Mediterranean countries, and data about the specific values are presented in this table of Gallardo and other authors. Seasonal crop water requirements, the ATC range from 170 to 370 millimeters, as you can see from this table. And the lowest values are generally for spring-grown melon and watermelon crops with 3 to 4 months growing period, while the highest values are found for pepper crops grown from September to late May. The reported ATC values for the soil-grown tomato, which is one of the most important greenhouse crops, range from 230 for the spring cycle to 260 millimeters for an August to January cycle. compared with equivalent vegetable crops grown outdoors with irrigation, open field irrigated vegetable crops. The seasonal evapotranspiration of greenhouse vegetable crops is appreciably lower than them, and this is for several reasons, due to several factors. First, there is a reduced evaporative demand inside the greenhouse, and which is mainly due to the decrease in the solar radiation. On average, it is calculated that 50% less sunlight reach the greenhouse crops compared with the open field vegetables. And in addition, under greenhouse conditions, there is a significantly reduced wind speed of the air, and the maximum wind speed inside the greenhouse is no more than 0.1 to 0.3 meter per second, which is significantly less than in open field. And because of that, the evaporative rates of water are significantly less than the open field vegetables. Secondly, the out of season vegetable crops are commonly grown during late autumn and early spring, when there are low evaporative demands, and because of that there will be relatively low values for crop water requirements, and this is very easily understandable. And last, commonly we use mulching in a greenhouse environment, and that significantly reduces direct evaporation from the soil surface, and due to that we have a significant reduction of the crop water use under greenhouse condition. Practically, crop evapotranspiration, ATC, is the product of the reference evapotranspiration, AT0, which is equivalent to the evapotranspiration of a grass crop, and which quantifies the effect of climate on crop water demand, and very importantly, the crop coefficient, KC, which quantifies the effect of crop species and the stage of development. Let's talk now about a very important issue, the water requirements of the greenhouse crops. As I said, the crop coefficients are experimentally determined for many greenhouse crops, and you have here the examples of Almeria in southeast of Spain. You can see that they have three different values: initial, maximum, and final. The initial values are very low, 0.2, and this is because of the fact that they correspond with the immediate period after transplanting, when the plants are still small, with a small leaf area, and because of that water, the evaporation of water is, the rate of evaporation is very low, and then the coefficient increases linearly and reaches its maximum values, which range from 1.1 to 1.4, depending on, of course, the species of the crop. As for example, you can see that there is a difference between eggplant 1.2 and tomato 1.4, but also it is depending on the crop management practices. I mean, whether the crops are non-supported or vertically supported, and you can compare, for example, non-supported melons, which has a coefficient of 1.1, with vertically supported melon, which has a coefficient 1.3. And then for some crops we'll have a final Kc, which is smaller than the maximum Kc value, and this is because of the senescence of the leaves getting older, and the plants are gradually reducing their leaf area. Because of that, they also reduce the evaporation rate, and also because sometimes for crops grown under late autumn or early winter, some cold damage can occur in the plants, which in general reduce the leaf area, and because of that the crop coefficients are also being reduced. These graphs express the curves of crop coefficients of supported sweet pepper and melon crops, and you can see that there are differences regarding the individual characteristics of each crop. For the pepper crop, figure A, you see that there is first a linear increase from initial Kc 0.2 to a maximum value of Kc to 1.4, and then there is a constant maximum Kc, which is followed by a linear decrease from 1.4 to nearly 0.8, and then this follows with a period of constant final Kc, different from the pepper in the melon crop. Following a period of constant initial Kc of low value 0.2, there is a linear increase, and a maximum value of Kc is reached, which continuously follows like that until the end of the crop cycle. So you can see that there are very significant differences in between the crops, and you should count this when you calculate the crop water requirements for plants, considering the different attitude of specific crops, but also considering the stage of development for each specific crop. However, we should say that for greenhouse grown vegetable crops, planting dates and lengths of crop cycle can vary considerably according to the market condition, weather condition, farm management considerations, and because of that, these standard methods of calculating crop water requirements might not feel properly every time, every case. I mean that you should sometimes correct these crop coefficients in accordance with specific situation you might find yourself.